Now, from this data set, you can see that you have only four factors here. Well, no. I only have 3 factors here, which are included or which are there in my on my questionnaire. They are there on my questionnaire. You can see for sex, you can see 2, 2, 2, 2, 1, 1, 1, 1, 2. That is representing male or female. You can see class stream. I think here I have like 3. I have 3. You can see 1, 3, 2, 3, 3, 3, 1, 3, 3, 2. So I have 3 levels. I have 2 levels here. I have 3 levels here. And for school type, I have 2 levels. So meaning I have for private and for public. Then training method here could mean the kind of methods I introduce them to. 1 could be a particular method. 2 is another method. Then 3 could be another method. I think the method, yes, the method.
Recording in progress.
Please, let's mute. So then I have for the training method, these are the methods that I use in teaching them. Then here, if you look here, I have pre-test assessment score. So this is pre. That means these are their score. These are their score before I administer the treatment. Then I have here post-test assessment, achievement score. That is the same test I gave this particular person before I administer the treatment. I also give the person the same test and he improves. So that's what you can see here. Then their attitude score. So this score comes in from the questionnaire, and that is what we'll be dealing with today. This score, we can see the pre. The pre means before administration of the treatment. Before administration of treatment, and the treatment is the training method which I have here. So for the pre-test achievement score, you know, I asked them series of questions, about 18 different questions like that. And I added all the whole score. I added all the whole score on it. And that is what comes about this total score for their pre-test. Then after administration of the training method, what is now the post-test score? So this is also the post-test score. The same questionnaire I gave to them for the first time is also the ones I gave to them at the second time. And by the time I added all the scores together, this is what I am having. So that is what I call the post-test score. And remember what we just said earlier, that we are going to look at one way. One way means we are looking at just one factor. We will pick one factor from here. We are going to pick the class stream because is going to compare their variances within the group and outside the group. That's what this ANOVA is going to do for us. And we are going to pick post-test score, the final score. So how do we do that? Remember, you ought to have done your what we call the 3 assumptions. So we are not going back into it because of our time. So you ought to have done that, which will give you permission to run this test. And there are 3 of them: normality, random, then homogeneity test. However, we are going straight now to do our analysis and which is one-way ANOVA. Remember, we said one way because we are only picking up just one factor to analyze. Now we go to analyze, we go to compare mean, and from the compare mean, we can see one-way ANOVA. This is one-way ANOVA here. You select the one-way ANOVA. After selecting the ANOVA, what is now your dependable list? Dependable list. What do you want to analyze? And that is what you want to do, which is what? The post, which is what you have there. Then what is the factor? One-way factor that you are analyzing is we are analyzing the class stream because we have 3 there. So we'll put it at the factor. So let me reset. Your dependable list is your dependent variable, which is what? This our post attitude. We look for it here. This is post attitude. You put that on your dependable list. Then your factor that you're analyzing, your 3, this is we are having 3 levels here. We put it at the factor level. Let's look at construct. What we have, you have nothing there. Post-hoc, remember I said we are going to do post-hoc later. After this class, we'll do post-hoc. So nothing there. Option, what are we looking for? All right, let's pick Welch test. Let's break Brown, homogeneity of variance. Then let's pick descriptive. So let's see what is going to give us. You say continue. Let me reset again and start all over. Your dependable list is your dependent variable, and this is our dependable variable. Then the factor, the 3, the within the group, within the group that you are doing. Let's pick class stream. Then we go to construct. We have nothing to pick there. Our post-hoc, we are going to run post-hoc later after this class, because should we have a significant, that's why we will run post-hoc. You don't just run post-hoc like that. If you don't have any significant, you don't need for post-hoc. But when you have a significant value, that's when you run post-hoc. So let's go to option. We pick Welsh, we pick Brown, Frochet, we pick homogeneity test. This is it. Then we pick descriptive. Descriptive will tell us, descriptive will describe all the variables, the factors in the analysis for us. So once you are done with all those ones, you say, okay. Then you wait, the SPSS do the one-way ANOVA for us. As you can see up here, you see one way. Excuse me, you see the one way. Then let's look at the analysis. You have your numbers here, and the numbers is trying to tell us that you have 97 people for science, 49 for commercial, and you have 61 for art. And it shows us our mean score, and it shows us our standard deviation, where it's actually getting the variances from, and all other ones you just neglect it. So we need this table. So we are going to copy out this table, so as one of the table that we will be presenting. Then if you look at the homogeneity test, you can see that we did not pass the homogeneity test. We did not pass the homogeneity test. But however, there is a saving grace for us. And that is where you can use this robust test. You can pick Welsh. We are going to pick Welsh. You can see that Welsh is giving us a non-significant value, because this homogeneity test of Levin test is giving us significant. So, and because it's giving us significant, we are not supposed to go further. But there's a big but in ANOVA, in the sense of this Welsh test. We just need a value that is not significant. So, and Welsh test is giving us a non-significant value, which also permits us to go ahead. You can see the robustness, even what we have in the ANOVA. So because I have a non-significant value here, Then I can go and interpret and use my ANOVA, which is what is here. You can see now the ANOVA test is giving me a non-significant. So how do you write out this, or how do you now present your ANOVA? What you need to do is you need this descriptive. But before you go ahead, you need to let us know, you will state in your report that your Welsh test give you this, a non-significant value, then that gives you permission now to go and do your ANOVA. And then you will start with this descriptive.
Test, sir. We can't see the Welsh test.
You are not seeing my screen. You should have talked since.
No, I can only see the data view.
You should have talked since now. Can you see it now?
Yes, we are just seeing it now.
You should have spoken up since. I said, so let me repeat myself. This is the result. You have the one-way ANOVA test. You have the descriptive, and you have the homogeneity of variance. The homogeneity, the Levin's test. If you look at the Levin test, this one has disqualified me from using this ANOVA. However, there's a robustness in ANOVA here. And the robustness comes from this Welsh test. Because I am having significant value for all these my homogeneity tests, I'm not supposed to continue with ANOVA. That's what it means. But there's a robustness. The robustness is coming or is given me from Welsh test. You can see, but before I can begin to interpret or give report of this my ANOVA analysis, I must state that my Welsh test is giving me a non-significant, which had given me permission to go ahead and use my ANOVA. And after I've stated that, I will come to my descriptive. This is my descriptive. So I'm going to list the group, list their numbers, list their mean, list their standard deviation. Every other one, I'm going to delete it. So I'm going to copy this and paste it in my work. Maybe I should just do that. You copy this, you click like this, you copy, then you open your Word. You open up your Word. Let me share my Word now so that you can see how I'm pasting it. I believe you can see my Word now. So I open up my Word. My Word is open. Then I paste what I had copied. You can see what I had copied. I'm going to give it a name, that is table 1. So I give it a name. So I'm going to delete all other ones, all these ones, because I don't need it when I'm doing my when I'm showing my analysis. So I delete that. Let me give it a name. That's table 1. So that will be this descriptive. And now you can give it an appropriate name. That is it. Then here also, I'm going to edit it. So I don't just give it like that. So I'm going to edit it so that it will not look as if I just lift everything just like that from my stuff. From the SPSS, IBM SPSS, just like that. So I'm going to do something that is much more beautiful, much more okay. Can give it this particular color. So you can see, then remember, you will turn this to 2 decimal places. All of them, you turn it to 2 decimal places, just like the way I've done. That is my table 1. So this is descriptive analysis of all these groups of the groups. So you give it appropriate name. As you can see up here, that will be your table 1. Then let's go back to let's go back to our analysis from SPSS. That is my table 1. Then the next thing I will also present is my ANOVA table, which is this one. So I'm going to copy my ANOVA table. I'll copy. I'll go to my Word. I'll paste it. So this is my ANOVA table. So, and also this one, I'm going to give it a name, table 2. And say ANOVA results. So that is my result. Then I'm going to edit this. So let me delete this particular one. So then let me re-edit this and make it look fine. That doesn't look as if I just lifted it from SPSS just like that. So let me use this. All right. So as you can see now, this is looking much more different from maybe I lifted it from my SPSS. So as you can see now, these are the 2 tables that you need. These are the 2 tables that you need. That is your presentation of the table. Now, the next thing you need to do here is now to state you state your hypothesis. That is your decision. You state your hypothesis, you state your findings, and you write in your shorthand. So how do I write my shorthand? Let me make it this one big so that you can see how I'm going to write it. You open up a kind of a bracket, open bracket, you have your F, open bracket. F is if you look up here, between the groups and within the groups, this is 2 by 204. This is 2 by 204. Open bracket. That is equal to, what is it giving you? It's giving you this. And remember, you want to have changed all this one to 2 decimal places. This will give us 4.3. This will give us 5.9. This will give us 408. This will give us 97. While this will give us 60. 60. So while this one will give us 21. So you say is equal to this F. You can say we say F, this particular thing is gotten because of this and this. This differences, this and this. So that is what you are going to have there is equal to this one, which is 1.60. Then you have your colon. Now say your P. You know, this one is what is greater than. You can see is greater than 0.05. So meaning that it is not significant. So that is what it means. It is not significant. Or you state it this way. You can state or you write your shorthand in this way. You say P is equal to 0.21. Either of the 2 is accepted. So you don't need to be stating colon difference 2 by 204 will give us F is equal to 1.60 is equal to 0.21. No, this shorthand had actually given us everything that we need to know or we need to write. You can see that doing ANOVA is very, very simple. And the one we've just done is one way. It's one way in the sense that we are looking at the class stream. We are looking at the class stream of science, of commercial, and of art. So that's the class stream we are looking at. We are not looking at any other one. So that's what makes it to be one way. So that is how to do your one way ANOVA. And by tomorrow, God's willing,